Hi y'all, I'm Derek from Distributed DBA. There are two truths that collide in this video. Schema changes are a fact of life, and many schema changes are blocking in MySQL, which reduces data availability. Since data availability is a key role for today's data guardian, what can we do about it? Keep watching to find out. Whether you use a relational database or a schemaless database, you will eventually have to handle changing the schema design. This is because requirements and features evolve over time. For the schemaless databases like MongoDB, this change likely is limited to adding or removing indexes as query patterns change. But for the relational database, the structure itself changes. This is why putting a little bit of thought up front is important, to keep those changes to a minimum. And that would be a good thing because in MySQL, many schema change operations are blocking. If you have a table of any significant size and you want to modify the structure, chances are good that the alter table command in MySQL will block. This means that any queries coming to the table will have to wait until the alter table command is completed. This would result in your availability crashing to the floor, especially if there weren't ways to do this in a non-blocking fashion. It gets even worse if your schema uses relational concepts like foreign keys, or if your application relies on downstream replicas to serve fresh data for read traffic. The good news is that there are options for non-blocking alters in MySQL, which helps the data guardian keep their data available. For instance, recent versions of MySQL allow some non-blocking alter directly. This is called online DDL. There are many operations that still can't be done online today, though, but these options are being improved with each major version. Online DDL still has other limitations, though. The main concerns are higher load on the database during the process that can't be throttled, additional space used for the copy of the table, and blocking replication as the change gets applied to the replica servers, resulting in large replication lag. The next option that I've used comes from the Percona toolkit, PT Online Schema Change. This is an external tool that will create a copy of your table, adjust the schema structure, and begin copying rows from the original to the new version until it has copied all rows. To keep the table fresh from changes to rows that have already been copied, triggers are set up. Once the copy is complete, then you can schedule a swap of the old table. This swap can cause issues, so try to schedule it during periods of low traffic. PT Online Schema Change still has the limitation of double disk usage during the copy operation, but it reduces the issue of replication lag and high load that the online DDL option has. The changes made on the source server are replicated to the replicas fast because they are small batches of work. To reduce load on the server, the copy process can be throttled lower during high demand for the database server, which online DDL cannot. But the performance impact can never be completely removed because of the triggers that exist on the old table. The final tool that I will mention is Ghost, the online schema tool from GitHub. Ghost also creates a copy of the original table with the new structure called the Ghost table. And it also copies the rows from the original table to the Ghost table. Similar to PT Online Schema Change, it requires double the disk space, and the events that are applied avoid large replication lag at the end of the process due to the small batches of work that is performed continuously. But instead of creating triggers on the original table, Ghost will connect to the binary log and modify the Ghost table directly. This allows the schema change to be throttled completely, removing any performance impact on the server. And the change can be picked up from where it left off when you kick it back up again during lower traffic periods. Ghost requires row-based replication, which can add significant disk usage to your binary logs if you aren't using that currently. One way to solve that is to run Ghost as a replica to your replica. This is actually the preferred architecture according to GitHub. So in this way, you can run your source database in mixed or statement-based replication to avoid issues with larger binary logs. Schema changes are a fact of life for any database environment. Even schemaless changes will require index modifications to any table or collection of significant size. In MySQL, many of those changes are blocking, and blocking of queries will result in reduced data availability for the data guardian. MySQL offers online DDL for some operations, but even that will require higher load on the database server that can't be throttled and will lead to replication lag issues later. There are several external schema change options, but I've highlighted two in this post, PT Online Schema Change and Ghost, because I've used both. While both options reduce load and the replication lag issues of online DDL, all options require double the disk space for the copy operation. So which tool you use will depend on your needs. I'm curious, what issues have you run into with schema changes? Leave a comment below.